Welcome to my channel about physics, robotics and embedded systems. If you are new to this channel or haven't subscribed yet, please subscribe via the thumbnail in the bottom right corner. The focus of this video is to start with again the analog input and output of the PiXtend PLC, which is controlled by RaspberryPi3 which in turn is connected via network cable to a laptop and ultimately controlled via SSH. The Raspberry Pi 3 is running a special version of Raspberry Linux, and my laptop is running Fedora Linux. And to see everything including the code, I will now change into screencast. Okay, screencast. Last time I introduced the for loop to get 25 times the input with which I can then give the output. However, after that comes this one, so I like to change the sequence. First channel 2, then channel 1, and see whatever freedom I get by doing that. Because this one, channel 2, just works fine. This one might work fine, but let's just check once again. So now I have to really run it, and it will run some more things than just the digital input, than just the analog stuff. This is, as you can see from the LEDs right here, the relays, and then as you can see on the oscilloscope what I'm changing with the screwdriver. Which will go for 10 times, okay. And you can clearly see that where the signals from the screwdriver or with the screwdriver are truly analog, the output is digitized, and I would love to see those values actually well, not digitized, because this is digital to analog and I don't like that. But maybe that is just what it is, and it runs quite nicely actually. So what's next to explore? Well, on the board are also the CAN bus, rs232 if I recall correctly, and of course the old-fashioned rs232. Well, old-fashioned, they are still in use. And a number of other topics. For some reason I still can't get the rs232 work functional. So now with the analog fully working, and you can see by the way that this is actually nicely working. Although what are the values anyway? Because this is 5 volts. So I would assume that this is 4, so much volts. I will assume so. Okay, next. Back to rs232 for a bit. Serial connection. using Python was already a nightmare, if you have seen those videos. But now I'm using C, and in C I have only this instruction to go, changing the serial mode, which is either rs232 or rs485. Not much to go. If you compare that to the analog input and output, or the digital input and output, then you realize that the capabilities of doing something with serial is not much. I can read the state of the relays. I can change the state of the relays, which I demonstrated earlier. I can set pulses modulation. I can set a servo, which is a motor. I can get the temperature, I can get humidity with the proper sensor. But to do something with serial motor, ouch. So unless I find some information about that, it ends here. And this is version 1.3, and version 2 is now common, well, sold anyway. So that is a problem, which means that I won't be doing anything really with the serial cable right now, which is why I wanted to check for the library before I attach the cable. Hence, no experiment with that. So, with the serial connection no longer in question, I have another idea, which comes back to pulses modulation. If you've seen other videos of mine, then you know what to expect. So I have confidence that this will work. Just point is channel 0. Did I indeed pick channel 0? And well, 125 is indeed a value that I can see. How long does it take? And by the way, it's this one that should show something. So this compiles nice, which is good. And let's run. I will let it to run completely without intervention of anything. No screwdriver for this one, no pressing here. I don't mind. I only want to see something on this line. And it's set to 200 milliseconds. So I wonder what I get to see. That's the digital output. Okay. Analog. That is something I don't expect to see, didn't expect to see. And whatever is happening, and it's already done. The program has ended. And I can't tell what happened. So I need to put a printf into it. Pulse modulation is a bit tricky in this case because I have got no result at all. This line is very nicely printed, as you can see right here. Then 125 isn't doing a thing. It may flash before your eyes without you noticing it. but then in comes the PiXtend tool, which I've shown before. And in this case, pulse modulation 0 and 1. Well, I have here channel 0, so I connected the probe to channel 0. I also put it to ground, so that's no problem. But problem is that no matter which value I put in here, it's not doing a thing. It's not changing at all. No results. So if I say 60,000, I see no difference, and it really is this one. I should see a change up here, and down here. Normally you have pulse modulation full cycle. So if say you have 100 and then 50 is halved, so with 50 you see half the period up, half the period down. What is 60,000? Is it entirely up, entirely down? If I say 0, or if I say, I have no idea, 500, well, with 60,000, 65,000, you should see something at 20,000, but I don't see a difference. So if I don't see a difference there, I don't expect to see a difference here as well. So where to go from here? I don't know yet. And with this riddle I say thanks for watching. If you like this video, please subscribe to my channel via the thumbnail in the bottom right corner. You can also follow me on Twitter and Instagram. You can also support by donating via PayPal or becoming a patron. And please do visit my website for all my other projects. This is obviously going to be continued. So for now, stay safe, take care, have a nice day, bye.